Let's play Code Wars. So the kata which is level at Code Wars is called even or odd, which is greater. And the instructions read as follows. Given a string of digits, confirm whether the sum of all the individual even digits are greater than the sum of all individual odd digits. Always a string of numbers will be given. did Yoda write this? I suppose. If the sum of even numbers is greater than the odd numbers, return even is greater than odd, because that is so much better than returning booleans. If the sum of odd numbers is greater than the sum of even numbers, return odd is greater than even. And if they are both identical, return even and odd are the same. Okay, should be simple enough. So we are considering, I suppose, integers from 1 to 9, I guess, or perhaps 0 even, but like the integer is just one character in this string. So let's again start by moving those from the string format to a number format. So const numbers is string dot slice with an empty string to get the list of characters again, and then let's map it with let's call it character, and then put it through the parse int like that. So now we should have a list of numbers. Then we can get the even numbers out, and that we can do by looping through the numbers and filtering out all the evens. So let's do just that. Numbers dot filter, and then we get the number and we check if it's even or not. And the fastest way to do it is by taking the remainder of 2 and checking if it's 0. If it is, then it's even, and then we can get the odds by checking if it isn't. We could do this with one reduce iteration, but I think this is much more clear way to do it. And now we have evens and odds, so we can get the sum of evens. So evens sum, and then we can have the odds sum, and these are basically the same thing, just applied to evens and odds. So evens dot reduce, right? And then we have A and B, let's call them, or left and right, and then we just plus the A and B, and then we give it a default argument of 0. So if there is just one item, and then we couldn't reduce it if we didn't give it a default argument. Or is it if it's an empty list, then we need the default argument. So the same thing, but for odds, a bit of repetition, but I think since we just have 2 cases, it's acceptable. So then we'll have the return clause. So if evens sum is the same as odds sum, then we return the value even and odd are the same. And, oh, misclick there. If the sum of even numbers is greater than the odds. So if evens sum is greater than the odds sum, then we return even is greater than odd, and otherwise we return the odd is greater than even. I think I want to do this the other way. So this would be the kind of last case, and we'll do it this by this. So odd is greater than even, and even is greater than odd, and if none of these is valid, then it returns even and odd are the same. So basically the same thing, but only if all the characters are numbers. There's a gist in here, because if you try to compare evens, or sorry, not if you try to compare not a number, I don't actually know what not a number does with the remainder. Let's try it out. What happens if we have a not a number? So if you do a parse int, for example, with this character, it returns none, right? And then if we do a none and remainder of 2, it's also a none. So it kind of dribbles down to evens. But, oh, or does it? Because then if we get the equality of 0, that's a false. But it's also, okay, so it's true. So none becomes odd. So it is possible that the odd is a none, because if you plus a none with, for example, a 0, it's a none, so it trickles down. So the odd sum may be none. Well, I'm just speculating here. Perhaps there is no test case for that, but in real world, if there's a bug. So then if we compare none with, for example, 0, that's false. If we check if none is greater than 0, it's also false. So in that case, if there is a none, so if there is a non-integer value in this string that is passed here, it will return even and odd are the same, because there is one none which will mess up everything. But I suppose the level 7 kata does not, oh, what? String.slice is not a function. Splice. Split. Yeah. So I suppose the second easiest levels of Code Wars don't consider nuns. That would be kind of awkward. Okay, so let's see how, oh, unlocked a new package. So let's see how others have done this, the same thing. So just splitting twice, using the shorthand of plus instead of doing the parse int. Yeah, that works. It's a bit shorter, but you'll need to know what the plus does. Mapping with a number is better than mapping with parse int, because you don't need this extra anonymous function for it. Because why I did it with an extra function is because parse int actually gets two arguments. So if you pass in 10, you can actually pass in a second argument, which is the base. So it's by default 10. But you can pass in, for example, 2, and then it considers this as base 2, which is binary. So in binary, 10 would be 2, right? So if you use the number constructor, you don't have any extra arguments. And why we need to consider that is that if we have, for example, 10.map, or let's say 1, 2, 3 map, and then parse int directly, it will bring up as none and none, because it will give the index of the element as the second argument. So actually it's like number and then its index that are passed to the parse int. Number index. So it boils down to this. So if you're using the number constructor, then you don't need to worry about this index. It's just ignored. So now you know. And copying your inputs, defensive programming, but if you are implementing a library, that might be a good thing to do. Or if you are dealing with other teams, that other teams of developers that you cannot trust. So basically, if you have code that you can't trust, then you might want to copy your inputs. That's called copy on read. That's another way of checking if the number that you have been passed is even or odd. Let's see what that does with nones. So if none is bitwise 1, oh, it works. Nice. So, well, it works as almost as bad as it would with. Oh yeah, so it works, I think, exactly the same as it would with our solution. But this is just using this kind of clever switch true. So a bit of pattern matching maybe, but not that much, because you're then overloading the cases with the true and false. So you probably would want to just use a regular if-else here. This is just confusing the read. Otherwise, regexes. So replacing, so you're using the string.replace, then passing a regex, which takes one character at a time, and this is a global regex, so it does it once for each element, and then you are doing the plus x is divisible by 2, and you are taking, you don't need to check if it's 0 or not, because if it's 0, it's falsy, so 0 would go to a minus, and then you would go to plus, and then, oh my, and then you are doing eval. So if you can see what's happening here, so this is constructing a large string of inputs and then running eval on it, and then checking if the result of the eval is 0 or greater or smaller than, greater or smaller than 0, and then if it's 0, it's the same. Well, this is I'm speechless, but at least this is not following the element of least surprise methodology. So basically you should never use eval ever, especially if the input of this even or odd cannot be verified, like if the user can provide the inputs, or if you can't be sure that this would be provided with an input that the user or the end user can give, then basically you are you're executing anything that the end user is giving to you through this eval. Not sure if it can be exploited because you are splitting each of the characters, but still. a pretty nasty way of doing this kind of calculation. Smart, but crazy. Like, smart. Don't do this kind of smart code, because you're not able to debug this when there's a bug in this. So yeah, that's all for today. Thanks for watching, and happy coding.